a bunch of the other contributors are going to be there, and I hope you're all going to be there as well. That would be awesome. Okay, so now it is my very great pleasure to introduce Jason Laber. He's from Google. What he probably hasn't said yet is that he used to be on my team. I used to be his tech lead, and then I upped sticks, left Google, and one of the last things I did is I went, Jason? And he went, yes. I went, how do you feel about tech leading the browser infrastructure team? And he went, I'm not sure about that. And I went, okay, goodbye. So please, Jason Laber, he's obviously suffered a lot because of me. I think it'd be really nice if you could give him a huge round of applause.
Thank you. So as Simon said, I'm the tech lead of the browser infrastructure team at Google. We're responsible for pretty much everything to do with testing with the browser. So that's maintaining WebDriver, Selenium, RC, provisioning the VMs that we test with, full stack, and it's quite a lot. So I'm here today to talk to you about how we migrated off of Selenium RC and got everyone at Google onto Selenium 2.0. We just finished this back in March, actually, and it was a pretty big deal for us because we've been working on it for a couple years. So when Simon heard that we had finally actually finished, because he didn't think we'd ever actually do it, so when we finally actually said we're done, and he heard about that at GTAC, he reached out and said, hey, you want to talk at Selenium Conf? And at first, I had no idea what I was going to talk about because migrating to Selenium 2.0 is really simple, really straightforward. But if it's so simple, why did it take us so many years to actually get it done? And to answer that, I kind of have to take you back and give you a little history of browser automation at Google. So that's what my talk's going to be about. So I started at Google 7 long years ago as an intern. And back then, for browser automation, we were using a tool based on Microsoft's COM API. It was IE only, and you wrote your tests directly in C++. So it's just as awesome as it sounds. And then I left Google, and when I came back as a full-time employee a year later, everyone had moved on to this new tool called Selenium. And everyone was like super excited about Selenium because they could actually test on multiple browsers. And my first day, my manager is introducing me to the new team, and a developer looks at me and he goes, so, you're the new Selenium expert. I had no idea what Selenium was, but okay, let's make it happen. So this was kind of the golden age of Selenium at Google. The Selenium farm had just been released, which is kind of a precursor to Selenium Grid. And everyone was in a mad rush to automate as much as they could. They didn't really care about test practices. People were just, we have to be automating, so let's automate. And it was kind of like a competition to see who could make the farm fall over first. The other big characteristic of this period at Google is everyone wanted to write a framework. I'm guilty of this too. We all wrote frameworks. There was competing frameworks everywhere. But nobody was actually focused on test quality. So this kind of created a backlash against Selenium. And Selenium developed a really bad reputation at Google. Kind of the phrase, everyone knows Selenium tests are flaky. To this day at Google, we don't refer to Selenium 2.0 as Selenium. We call it WebDriver. It was a very permanent blow to Selenium's reputation. And there's also some tool fragmentation going on right now. People weren't happy with Selenium because they couldn't get their tests stable, so they started coming up with new tools. One of those is managed to kind of hang in there. It's called Web Puppeteer. It's actually been open source. You can find it on Google Code if you're interested. But so today, the two big frameworks at Google, the two tools are Puppet and WebDriver. So I worked on Google Docs, and we eventually moved away from Selenium because, like everyone else, we couldn't get it to work for us. And the type of testing we were interested in, Selenium just wasn't working at all. So we started moving into more on the JavaScript unit testing side. We started using an Apache HTTP client to test the protocol level. And we were really happy with that for about a year. And then one day, a developer came to me and said, we're just getting slammed with these formatting bugs. How on earth are we going to fix this so people actually enjoy using Google Docs? So I knew Selenium was out. Selenium RC is a JavaScript application, so you can't actually automate a rich text editor. The DOM will fire all the events you want, but it won't actually update the content. So I started looking at the Java robot, which if you've ever had trouble synchronizing a test with an Ajax app, just throw the robot in and you'll want to bang your head against the wall pretty hard. So we spent about a week with that, and then we moved on. And then I heard about this crazy Brit who was working on a new tool that could supposedly generate native events without stealing window focus. That's, of course, Simon and WebDriver. So Simon was in Mountain View, and I managed to get a meeting with him, and I laid out all of the use cases that we had on Google Docs that we wanted. And in true Simon fashion, he looked at me and he goes, OK, why don't you join the team and help make that happen? So that's how I came to join the WebDriver team, and I've been causing trouble ever since. So WebDriver had all of the big buzzwords that people at Google were desperate to hear. It bound tightly to the browser. As an interesting aside, the IE driver, like that first tool I used at Google, it's based on Microsoft's COM API. It's IE only. You only have to write your test in C++ if you're a masochist and want to do that to yourself. So WebDriver was this new brave frontier of browser automation. And it had a lot of buzz, but it wasn't really going anywhere yet. So shortly after I joined the team, Simon and Jason Huggins had their famous steel cage knife fight, and they merged the open source project. Selenium RC was declared version 1.0, and WebDriver became 2.0 and was the future of the Selenium project. And this created a pretty interesting problem for us at Google, because we had invested very heavily in Selenium, and there were hundreds and thousands of tests out there. So how on earth were we going to get everyone to start using WebDriver? To kind of understand how daunting of a problem this was, how to do this smoothly, there's a few facts about WebDriver or Google's development environment that you need to know. Today, Google has 15,000 developers. We all work from a single code repository. There are 20 code changes per minute. 50% of the code turns over every month. Everyone builds from head. So the only way we maintain our sanity in this environment is we run lots and lots of tests. It's somewhere north of 100 million test cases are executed every day. A small fraction of those are what we call web tests, and that's any test that needs Selenium or WebDriver to launch a browser. I can't give you an exact number on the number of web tests we have, but I can tell you that we're seeing over 3 million unique browser sessions started each day. So we run lots of tests. So to migrate everyone off of 1.0 onto 2.0, we had to do this very calmly in an orderly fashion so that we didn't disrupt release schedules and just the normal environment at Google. So at first, we decided to just kind of ignore the problem and just keep our heads down and carry on and focus on WebDriver. We were very lucky that Google believes so much in browser automation that they just staffed a team of engineers and said, you handle the Google side of things, but you can also work directly on the open source side of WebDriver. So we were able to focus on building out the features that developers said they needed for Selenium. One of the big things that we were missing was browser coverage. When I joined the project, WebDriver was still IE and Firefox only, and this was held against WebDriver a lot. A lot of teams, they were happy that they could test pretty much any browser they could think of with Selenium, and they weren't even interested in considering WebDriver until we increased our browser coverage. So we wrote a version of the Chrome driver based off of Chrome's as a browser extension, and that helped a little, and it got some people to start playing with WebDriver, but for the most part, they just weren't interested. So we just kept going in, and we figured if we made WebDriver good enough, eventually they would see that, they'd recognize that. I mean, smart folk work at Google, surely they'd recognize greatness when they saw it. And it kind of worked. We had a few early adopters, and they were kind enough to point out all of the glaring flaws and usability issues that WebDriver had in that sort of curt style that is unique to Google engineers. So we just kept working, and we eventually realized that each version of WebDriver weren't being very smart about how we were doing things. Firefox was implementing, for example, the isElementDisplayed check one way, and IE was doing it another way. And we'd fix a bug in Firefox, and then a week later someone would say, it's still failing in IE. And we're like, we forgot to fix it in IE. So eventually we realized we got to be a little bit smart about this and kind of unify all of this logic, and that's where the browser atoms library came about. This is the JavaScript library that is used throughout all of the WebDriver implementations today. It defines all of the atomic operations behind anything you need for browser automation. So we have, is an element displayed? Can you give me its visible text of an element? We even have user emulation in there for generating click events for the browsers that don't have native event support. So this is all written with Clojure, Google's Clojure library. So the code is very verbose, but it makes it easier to maintain and test. And then we use the Clojure compiler to optimize the various bits, or we call them fragments, and down further. So for example, web element getText, if you just took all of the JavaScript files involved in defining that function and you concatenate them together, you'd have 570 kilobytes. If you optimize it a little bit, strip out your white space, you end up with 500 kilobytes. Go a little bit further and do some generic optimizations, you end up with 50 kilobytes. And then you can really crank it up and tell the Clojure compiler to strip out everything that isn't related to Chrome. And we have to write the code a certain way and kind of like see preprocessor macros in JavaScript, what they look like. But it really gets that 570 kilobytes all the way down to, as felt, 30 kilobytes. That's a nice manageable chunk of JavaScript that we can inject into the browser. So like I said, all of the WebDriver implementations today are based on this. And we're able to use this library to really accelerate the development of new WebDriver implementations. If you go into the Chrome driver code base today in the Chromium tree, you'll see they have a header file, atoms.h, and it's just huge C string constants that are generated from this library. And it's because of this library that we were able to get the Chrome team to implement the Chrome driver that you know and love today. So you can see here that when we released the Chrome driver, it was kind of the impetus we needed to get developers to finally sit up and take notice of WebDriver. We had IE, we had Firefox, and now you could test Chrome, Google's own browser. And it was stable, and it worked, unlike Selenium RC for Chrome. And so we just had this natural explosion in usage of WebDriver, and people started just moving off of Selenium. And about this time, Simon also wrote the WebDriver-backed Selenium and Selenium-backed WebDriver to help people with the migration. But for the most part, it was either they just started over and used WebDriver directly, or they just ignored us and continued to use Selenium RC. And for the teams that would never actually move to WebDriver, we'd always go to them and say, well, what's holding you back? And it was that same, well, you don't have browser coverage. And so, well, you have Chrome, and then Opera came out with the Opera driver, finally released it to open source, and we said, well, now you have Opera. I'm like, yeah, but you don't have Safari. So, okay, well, go write a Safari driver. So this takes us to 2012, and we released the Safari driver, and so we released the Safari driver, and we finally said, we've got all of the major browsers covered. There's iOS, there's Android, there is Chrome, Firefox, IE, Opera. We have all these browsers covered. There's no excuse anymore to keep using Selenium RC. We're going to standardize everything on WebDriver. Problem is that there were still thousands of tests written for RC, so it wasn't something where we could go in and do it ourselves. We needed to convince the teams to help us and migrate their own tests, take ownership. But we couldn't really get them to do it, so we started being a little more forceful with it. Now, like Google, we have our infrastructure set up so that everyone requests a WebDriver instance through a builder class, and this class intelligently looks at the environment you're running your test in and decides what type of setup to give you. So it'll detect, okay, your environment is configured for Chrome, I'm going to launch Chrome, or I'm going to request a VM with IE on it. So we went into that system and we tweaked it and we said, okay, if the request is coming from RC, They get Firefox 3.6. That's it. And teams would come and complain, and we'd say, oh, you wanted to test IE in modern browsers like Chrome. Yeah, you're going to have to migrate to WebDriver. Sorry. And that actually seemed to work. Teams sat up and took notice, and they started migrating. Problem is, there's lots of teams that had been using Firefox 3.6 since pretty much we introduced that configuration when 3.6 was released. And they ran all of their unit tests on modern browsers, and they had all sorts of other ways of testing. But their system tests were rock solid, stable green on 3.6. And they were happy. They could care less. They had no interest. Their tests, they were used as to validate releases, and everything was working for them, so they just moved on. So this comes to last fall, right about the time that Simon had enough and bailed on us. We decided it was really starting to become painful for us because we were trying to improve WebDriver, make it better, and come up with new features for our infrastructure. But every now and then, someone would come and say, oh, RC is broken, can you help me? And it was just getting really annoying. So we finally put our foot down and drew a line in the sand, and we said, all right, February 2013, your tests are going to break. They're not going to pass anymore. But remember what I said about Google's infrastructure. Everyone builds from head. So it's not really considered polite to actually break people's tests intentionally. So this meant that to get people to get off of RC, and so we could actually get rid of it, we had to go in and migrate their tests for them. So from about October until this past March, myself and a couple other members of the team, we'd periodically go through and identify a new team that was still on RC and forcefully migrate them. And we'd send them the change, and they'd say, oh, that's really straightforward, that's simple. It's like, yes, it is. Huh? That actually never really saw too much adoption. Simon was calling out, what about WebDriver back Selenium, which I'll talk about more in a bit. But that was supposed to make it super easy, and maybe 3 or 4 teams moved to it until we came along and said, you don't get a choice, we're going to move you to WebDriver back Selenium. So when we finally finished cleaning up the code base and getting everyone off of Selenium RC, we were able to go in and do some cleanup. And the first thing we did was we actually updated the version of the Selenium server that we deploy. And until this point, we had just been using what is available to you on the Selenium project download page. But we went in, and since it's just the driver servlet, it's just a servlet, so all you need is a servlet container. So we just wrote a quick one of our own, and we removed the Selenium RC endpoint. So if you happen to have a Selenium RC test that we missed, and you tried to go run your test, well, it's not going to work anymore, so sorry. So after this, we also were able to go and look at all of the Selenium RC usage that was in Google. So we had everyone switched over to WebDriver, or they were using a WebDriver back Selenium. So it was all WebDriver under the hood, but there's still lots of people using the Selenium 1.0 API, and we were able to go look at that and actually identified over 100,000 lines of code that was just sitting there, not actually running. So we just got to delete all that, it's always fun, deleting code. And we were also able to simplify our own infrastructure. We had developed a lot of debt over the years as we had added features. So I mentioned we had this builder that creates a WebDriver instance kind of intelligently. And originally it was just, you ran Firefox on your local machine, so it just kind of abstracted away the call to the Firefox constructor. But then we integrated with the Selenium farm. So we had to add in some logic for, okay, well, this is a remote WebDriver instance on the Selenium farm, and there's a special API call you need to make to tell the builder that you want the farm. And then the farm had its crisis of constantly falling over from all the traffic people were sending at it. So we kind of deprecated that, and we built a new piece of infrastructure, which is the grid that we use now. It's a VM-based solution, kind of what Salesforce was talking about earlier today along those lines. But so that was even more complexity to the builder. So just over the years, we just kept, there's a need that developers needed to test their apps, so we would just tack it onto the builder. And it got really nasty in that code. we had a new developer join the team, and he was trying to implement a new feature. He wanted to add the ability to record videos of your tests. So he had to go into the builder and add the appropriate functionality there. And he came to me and he's like, I can't understand what this code is doing. I was like, well, there's the browsers class, and there's the drivers class, and there's filters and generators, and what don't you understand? And he's like, oh, okay, I'm just going to clean it up first. And I was like, okay. A month later, he sent me a CL, and he was sitting next to me, and he turns to me and he goes, okay, before you complain, I know this CL introduces a WebDriver factory. But just hear me out. And sure enough, with that CL, we had a WebDriver factory, and that had a WebDriver factory. And then on top of that, we had a factory. So that was very temporary, but it was necessary because we have this build system where everyone's building from head, so we have to be really careful when we're making changes to this infrastructure so that we don't break a team and they come chasing us down and demanding a rollback immediately. Oh no, that's not good. Let me see if I can fix it. Huh? Yeah, let's see if I can get it.
Good job. Who wrote this stuff? Who tested this stuff?
Not I. All right, so yeah, the factory of factories. That was a short-lived intermediate step to cleaning up our code base. But today we have a much simpler, streamlined set of infrastructure so that we can actually start thinking about adding new features. And we're constantly coming up with new ideas for how to simplify things further now that we're not tied to Selenium RC still being in there. There's just one type of browser automation tool. We can get rid of all that old stuff, and we've even started playing with new ways of sending commands back and forth over the wires, so kind of alternatives to the JSON wire protocol. Hopefully we'll be able to share that more with you in the months ahead. Yeah, so that's kind of the story of our migration at Google. It's a very long, drawn-out process, and it sounds really hard, but at the meat of it, it's just inertia. What did we need to do on the infrastructure side to make WebDriver appealing enough to get developers to migrate? The actual migration process is really straightforward. It's just 4 simple steps. So first, you need to clean up your tests. Turns out that tests that are easy to maintain are tests that are easy to migrate. You don't want to reference the Selenium API or the WebDriver API in your test ever, because then when your UI changes, you have to go through and find all of those references to that ID or that XPath expression. So first thing you want to do is you want to go in and actually build proper abstractions. It's just basic code health for a WebDriver test. So once you have a page object in place or some other abstraction that's appropriate for you, then you have all of your logic in a centralized place, and you can just swap out huge chunks of functionality, and your test won't be none the wiser. So the second step is to use a WebDriver-backed Selenium. So the WebDriver-backed Selenium is exactly what it sounds. It's the Selenium API, but it's WebDriver under the hood. It's an emulation layer. It's 3 simple lines. It's available in Python as well, but you have to use the remote server to get it in Python, so it's server-side instead of client-side. But the WebDriver-backed Selenium, your tests keep using the Selenium API, but under the hood, if it's a simple thing like click, then Selenium.click is a WebDriver.click. But if it's something more complex, then we fall back on that browser atoms library to emulate the Selenium core or Selenium RC behavior. So once you have Selenium or WebDriver-backed Selenium in your test, you now have a Selenium instance for all of your existing functionality, and you have a WebDriver instance. So every new feature you cover with tests, you want to use WebDriver instead of Selenium. And as your tests break, then you want to go back and replace that broken functionality with WebDriver. And you just kind of do this slowly over time, because under the hood, you're already on Selenium 2.0. So you just kind of slowly, incrementally update your actual code, and before you know it, your code base will be 1.0 free. So we also have a Selenium-backed WebDriver. And this is for if you're testing some obscure browser that doesn't have WebDriver support. We use this at Google for Safari to get a few teams to move off of Selenium early. When they were telling us, well, we positively can't do it until there's Safari support, we said, OK, well, what about Selenium-backed WebDriver? And a few teams tried it. Most of them just couldn't be bothered, but we tried. This is an option there if you want to test, I don't know, Camino or Conquer or something. This is an option in the Selenium code base, but you probably will never need to look at it. So that's all you need to do for migrating. It's, like I said, it's super simple. You just need to commit. Just need to tell yourself we're going to do it. And you go in, get your WebDriver back Selenium, and you start updating API calls as you go. You don't need to rewrite your tests all at once. You don't need to invest a ton of resources. You just need to do a little bit at a time. But there are a few common pitfalls that you need to watch out for. The first one is alert handling. Selenium has this weird record playback style of alert handling where it's actually overriding the JavaScript functions to capture those alerts. So you tell it, OK, the next time a confirmation appears, cancel it. And then you click. And presumably, a confirmation happened, and Selenium got that and recorded it. And if there wasn't, you get an error. WebDriver is more a natural, reactive approach. You click something, the alert pops up, and then WebDriver lets you switch to it, and you can either dismiss it, accept it, or what have you. So this is a kind of a place where the two APIs are completely incompatible. You can't reactively respond to an alert with the JavaScript in Selenium because it's a modal dialog. It suspends the UI thread. So you have two options. You can go with what WebDriver back Selenium tries to do, and it tries to emulate Selenium's behavior where it overrides the alert functions. The problem there is that if you have an alert happen right at a page load boundary, so users filling out a form and they click OK and they missed a field and an alert pops up and says you can't submit yet. WebDriver could catch that, but the WebDriver back Selenium isn't going to be able to because it's going to record it in JavaScript, but then the page is just going to go ahead and reload, and then that JavaScript variable that was saving the alert is gone. So now your test is failing, and it's really confusing. So the first thing I would do after putting in WebDriver back Selenium is I'd go through, and if I couldn't convince the devs to be kind to our users and get rid of alerts, I would go through and get rid of all of the alert handling that was using Selenium RC and just switch it over to WebDriver. It just takes a few moments. So you get all the alerts handling done, and you're good to go. Okay. Next thing to watch out for is wait for page to load. This is just checking the document ready state. For WebDriver, it's already kind of implicitly doing this when you load a page. So just save your tests a little bit of time and get rid of those wait for page to load calls. You're still going to want to follow best practice and explicitly wait for the element you want to interact with. But this idiom that you see all the time in Selenium of open google.com and wait for page to load, just save your test a little bit of time and get rid of that call. The other thing that you're going to see is get body text. I don't know why, but people love to say Selenium get body text. Text contains hello. And they switch to WebDriver and they try and do the same thing, and they say, oh, my test is slow. Well, remember, get text is 30 kilobytes of JavaScript we have to execute, and it's got to traverse the entire DOM. It's a depth-first traversal, and it's checking each node along the way. Is it visible, and is this text that the user is going to see? And it's an expensive operation. So if you apply this to the body tag, yeah, your test is going to be slow. And if you do this and you come to us and you complain, we're going to say, don't do it. Just find the element that has the text you actually want. If you're looking to verify the text on a form field, then go straight to that form field and check the text there. Don't try and build the text for the entire page. If you do want to search the entire page, just get the page source and do it that way. But don't do it through get text. Your test is going to be slow. The other thing to be careful with is JavaScript. You need to be really careful with JavaScript. People love to just use Selenium RC as a JavaScript execution engine. You can just inject whatever you want into the page, and since RC is just a way of remotely controlling the Selenium core JavaScript app, you can call directly into that API from the JavaScript. Problem is, WebDriver doesn't have a Selenium core. There's no JavaScript API there, so we have to emulate it. We have to intercept these get eval calls and transform your script. So this is a really simple example here. Selenium is element present, is element visible. So what does this look like after we've transformed it with the atoms to work with WebDriver? Let me zoom out a little bit more. Ugh. Just one more time. So WebDriver back Selenium is not efficient at all. We didn't even focus on efficiency ever. We just wanted something that works, and we wanted it to be accurate. And you will get accurate behavior. It's going to behave like RC does, but it's going to be slow. Your test, when you switch to WebDriver back Selenium, it's going to be noticeably slower, especially if you do this kind of stuff. So watch out for it. And if your tests are slow, look for get eval calls that are referencing the Selenium Core API. So just to wrap it up, migration is 4 simple steps. Clean up your tests, get rid of those direct API usages, swap out your default Selenium for a WebDriver back Selenium. Use WebDriver for all new features. If you see a developer trying to use Selenium RC again, tell them, nope, go work on it some more. And then as things break, go ahead and move them over to RC. And that's all there is to it. Any questions? Yeah.
What's your recommendation on handling browser file download?
Okay, so the question was how to handle file downloads?
Yeah.
My recommendation is don't do it with WebDriver. You're not actually testing. You can test it with the browser, but you don't need to. So if you absolutely wanted to test it with the browser, you would want to configure a Firefox profile or Chrome to automatically download files of a certain type to a location. So you just click the link and Firefox does its thing, and then you can monitor the file system for when it's done. What I would do is, because what you're actually doing is fetching a file from the server, so I would just use a plain old HTTP client, fetch the file from the server, and then do whatever you need to do with it. But I think doing that with the browser just adds complexity to your test.
How exactly does the WebDriver, when you go to a URL, know that the page is finished loading? Because like we now have things where you do like constant polling, for example. So how could that affect whether or not it knows that the page is loading?
So WebDriver binds pretty tightly to the browser. So how it does it depends on the browser. And there's no common way. So for instance, in the Safari driver is implemented as a browser extension. And you can configure the extension to load scripts at a certain time in the page load cycle. So you can load a script as soon as the DOM has been loaded, but it hasn't been parsed yet, or you can load a script right after it's been parsed, but before window on load fires. So that's what we do for Safari. We use the extension lifecycle to keep track of the state of the page. That adds a ton of complexity to it too. For Firefox, it's again a browser extension, but Firefox is far more permissive with what you can do in extension. So we're actually able to hook directly into the browser's navigation system and listen for events, native COM level or XP-COM level events as to what it's doing. And we don't always get it right. We try to detect where the browser is in loading stuff. There's actually an open bug right now with JSON-P in Firefox, where the Firefox driver will think the page is still loading, but it's just JSON-P. And so someone has to go in and figure out what that type of network traffic looks like, and how to tell the driver that, yeah, you can proceed at this point. Again, Chrome does something similar where we hook into what the browser's doing and kind of make a best guess as to, okay, the browser is ready. And this is why we say that WebDriver waits for the page to load, but it's round about when onload would fire, but we can't guarantee it. And that's why you should always use explicit waits. If you're going to interact with an element, wait for it to be there. A what?
Uploader, so you're
Okay. So the question is there a way for WebDriver to interact with native Windows? The answer is yes, but we've declared that out of scope. So we haven't implemented it, and we have no plans to. Yeah.
How does Google deal with long-running tests? I mean, do you have some?
So the question is, how does Google deal with long-running tests? So we have several different ways of running tests. There's the standard system that, like a kind of a continuous integration system. There is strict time limits on how long your test is allowed to run there. And if you need more time, then we have a different system that's set up explicitly for these long-running tests that are very resource intensive. So if you have a test that needs like 2 hours to run, then you have to set up your test differently to use this other system. So we kind of segregate them out. And the test runner enforces those time limits very strictly. So the moment you hit it, your test times out and you don't get any results. You get the timeout error. Anything over there? Yeah.
How do you do your internationalization test or the translation?
I know.
Will the developers put tags in where the labels?
I know that there have been tools built on top of WebDriver, but I don't know what they do. So that's kind of, our team focuses on actually supporting WebDriver, making it possible to run the test, but we leave it up to the individual teams to come up with how they want to use it and kind of innovate. So like Michael earlier had a lightning talk on performance testing. When WebDriver doesn't work for iOS, he'll come pester us, because that's kind of our area. But the whole performance testing thing, that's a tool that his team came up with and maintains. So, yeah.
How do you guys enforce good practices when it comes to writing tests and ensure that they run the whole company?
So the question is, how do we enforce good test writing practices? We don't enforce it. We publish guidelines, like these are things we recommend you do. These are the best practices. You're going to have a hard time if you don't follow it, that kind of thing. And various teams have come up with solutions. A lot of teams use the page object pattern, and we have a users list where people are able to post questions on. And for a long time, we had to curate that ourselves, but we've kind of finally reached a point in WebDriver's adoption at Google where other engineers are able to jump in and say, oh, okay, you're trying to do that. This is what you want to do. This is how you should be writing your test. Yeah.
Are your best practices available for public consumption?
Yeah, it's the Selenium wiki. We don't have anything internal in that regard. We actually have pretty little internal documentation. All of our internal documentation is for the internal systems. Everything else we try and contribute back to the community as much as we can. So yeah, the page object pattern that I referenced in the talk, that's fully documented on the wiki. There's also, the bot pattern? Is that what you called it, Simon? So yeah, it's all in the Selenium project, not Selenium HQ, but if you actually go to Google Code and look at the wiki there, there's a lot of stuff there.
The migration steps that you talked about, some of the pitfalls are on the Selenium HQ docs and then appendix.
Okay. So not all of the docs are in the wiki, some of it's on Selenium HQ. Anything else? Fantastic. Thank you.